present yourselves and then start presenting the project.
César López Manso, A01660536.
Pablo Manuel Garrido Juárez, A0166-150.
Samuel Sánchez Flores, A01665416.
Santiago Montoya, A016-66-203.
Felicitas, and I don't know my number.
It's okay. So now present the project that you have developed.
Okay, so the project we already know, it's a project that combines automatization with PLC, with other parts of mechatronics, right? So right here we have implemented everything. We have three insertion stages with different colors for the different viscosities that you have to achieve. We have the viscosity meter itself, which performs the viscosity measurement. We have a pump that gives water to the glass, as it says, bottles, so the viscosity is achieved. And we have a couple of sensors, well, many, which include a color sensor, ultrasonic sensor, induction sensors, infrared sensors, and they will control that everything happens when we want to happen, basically. Now we have a sorting station which sorts for the three different viscosities, and we have a station for the trash, for the bottles that don't achieve the expected viscosity. So it goes right here, and the arm over there pushes the bottles into this station whenever it is necessary. The viscosity meter turns to different stages of where the spindle needs to be. This includes a station for the cleaning of the spindle and the drying of the spindle after it is cleaned. And well, the band itself to move every single glass or bottle through each station until it makes it to the end. That's basically it. We have also a control panel which we made so we are able to physically control everything. And well, yeah, that's all right.
So can we proceed with?
Yeah.
Okay.
Which color do you want?
Okay, let's say white.
And you, please?
White.
The second one, red.
Blue. And the last
And
one.
another blue.
There was some more positions.
Chispas. Here I can see that the stacker is not full, indicating that it's half or just one level.
Okay.
The other one is showing that the blue one is still full and the red one full. Here with this red light I can show you where is the worst part of the stage, that it's on the conveyor belt.
I don't know why, but the ultrasonic sensor didn't work this time. It happens not that many times. We have proven that.
Can I play again?
Okay.
No va a continuar el PLC si no lo ponen en el ultrasonic. It's a great time to show you the emergency stop button.
That's why we do it.
That's exactly why.
Nah, the thing
Even
was,
if I release it, the conveyor belt or any motor won't work until I press the reset button, this one.
Okay. So let's say that the button is the resume.
That's right. Now the white LED is showing that the process for that is complete, and it's going to stack it now. Well, to sort it now in the white.
Well, at least you should be detecting that the viscosity adjustment process wasn't performed.
No,
so
it's going
in that
for
case,
exactly.
you will have to reject the container.
Yeah, in this case. But
¿No se está moviendo la banda?
I don't know
Se
why.
está chocando.
No, pero no se está moviendo la banda.
Por eso.
El tiempo de...
I think our batteries.
That
Died.
hadn't happened before. No, pero se está moviendo, güey.
Sí, se murió la batería.
Ahora. Sí, pero no la de la banda. Está avanzando. Creo que se actoró.
Se está moviendo el
Well,
motor.
we developed the viscosimeter. We use two steppers.
no
All
sé
of them are implemented with PID. We use the edges that are used in the stepper with the PWM in order to know how we are going to change the frequency. And that response with the PID coefficients give a really smooth operation. You're going to see it in a minute, but I don't know, the batteries didn't work.
Safety
right now.
question, can I like give it a little charge to the battery while it's...
Ah, I know why. I know why. Tienes mal el este. Me estás mandando señal con el ultrasónico. O sea, el problema es esto.
Okay.
no yo.
It's a little false.
As you saw, because of the stepper, well, because of the viscometer part, it blocked the band. So that's what happened.
Los destapes están para-
Ande. Ok, ¿dónde? Ahí está. Ahí está. ¿Lo quiero bajar? Ya está. Ahí está.
So this is the expected position of the viscometer should have. It waits. Here,
Ay, perdón. Sorry, I moved it, sorry.
right now you should see it.
Es que se cayó este. Ahí está. It's a little false. It's like not making the contact well.
Yeah, it restarted all over again the band. So we have the echo that we are receiving from the ultrasonic. Then the state machine will read the color sensor. It's powered via I2C. And we made that communication. Then it should lower the spindle. So I think maybe in the last part you're going to be capable of seeing it.
Ya está acá. Que es un poco es un poquito helado.
And we have another one that goes there.
No, esa, sí.
And the last one, that's the blue. As you can see, it follows the sequence of which color has been pressed. So in the PLC part, it's doing the sequence of color and sorting it. As you can see, the sorting system didn't move. It stayed on the blue one, so it knows that it's going to that color.
Yeah, but according to your process LEDs, the first one is only that the system is delivering, the second one is that it's in the viscosimeter, and the last one is that it's in the sorting station.
Yes, it's going one by one.
Well,
They
at
are
least,
not turning on because I don't know what.
yeah, at least in the case that the viscosimeter is not working, so that's the reason the LED from the viscosimeter process is not turning on.
Yes. That's the third one.
So
The red one, this one, is for the conveyor well going on. and the orange one for the and the black one, the white one for the sorting.
Now that the viscosimeter is working, why it didn't change the LED?
Yeah. You can see we have 30 RPMs that are controlled via the quadrant encoder. We have the steering part. In case that it mixed, we should steer it.
Shouldn't there be some waiting time before steering?
No, I don't think so, because there is no need, actually, if you think about it. The viscometer already delivered a filter value of viscosity. It's met or it's or isn't, so there is no really big change. And now it's waiting to let the phone work. So yeah, exactly. We have 3 powers that are doing it.
The movement is kind of.
Yeah, the movement. Yeah, but it wasn't in the
Maybe
last part.
because of the battery. That we're having problem with the battery.
Yeah. Also, I don't know why.
I don't know.
Yeah.
I see that it's mixing steering, but I don't see water being applied.
Yeah, that's a problem.
Okay.
And also it's not reaching the soap, so you're not mixing anything.
Yeah, exactly. The problem here is that because we don't have a quadrature encoder also for the stepper part, we can't know if we have lots of steps. That was the problem right now. So because of that, we can't like get real feedback of if it reached the water. It worked almost every time that we did it, but right
Also,
now.
yeah, it didn't reach the so because back here they secure that stuff that
Yeah, we
the
have a mechanically
viscosity
designed
open.
problem. As here, as you can see, we have these straps that lock the movement. But also, there's kind of a little problem that when you are really high and it tends to go up, it gets trapped here. So that's one thing that might be remarkable. So we must look at it.
Your song being played?
It should. It was in the beginning and one cycle, but then I don't know why it didn't work. So yeah, I think this is the last step. We have here the lectures of ADC, the error, all the RPMs that we're having.
And also I think that the computer started before seeing
Yeah,
this
because
table.
well, the problem is that the sequence was designed in order that this should go up and then go to the cleaning positions. Because of the problems that we had with mechanical design of the shaft that's included down to rotate, therefore that was a problem and it can rotate. So the sequence should be goes up, waits the band, waits like 1 or 2 seconds, and then we can pass it. So therefore, if we use that, we will save time. But that didn't work.
I think it
And you place a joystick into your control panel, so what's the purpose of that joystick?
It just was for the manual cycle, but as it's
Yeah,
not
it's,
necessary anymore for the viscosimeter part.
It has purposes of calibration,
No.
like to put the spindle facing the right way, checking if the actuators work, and all of that.
Now I can put a new sequence of what?
Yeah,
Which one?
red, blue, red.
Oh, red,
That's cool because we don't have any whites.
blue.
I know it. That's the reason I asked for that sequence.
creo que el copia se lastimó.
Sí, hace rato se estaba doblando cuando lo levantaba. Me iba en medio.
Y hace
¿Quieres
otra vez.
jalando?
No,
No, es sobre. Ahí está, ya lo jaló. Ay, güey.
¿Qué acabas de reventar?
Todas mis pinzas. Cosas que pasan.
¿Puedes acercar el extractor rojo? Está muy lejos.
Sí.
No tanto, nosotros.
For the part of the picosimeter, I think that this part, the ultrasonic sensor is having a little like, I don't know, it's not a short, it's like a false connection that is making like it's making it, I don't know, because it's explanation, that is making it like don't receive information because of the long cables. Because
Well,
the first time is when I push it, I think the ultrasonic sounded with the buzzer. Presiona la parte, presiona el seguro. It's something like should be like this.
Yeah.
It detected.
It exactly for this that we have the calibration. Like we determined that the step was there, but finally it wasn't. So
It broke. Touch it.
you can hear that it's
The couple
using
broke.
PID.
Y compras elástico.
¿Se lastimó o se
can we measure the spindle speed in the lab view panel?
Yeah, we can try.
We can try.
That's not a couple.
Why didn't you? I thought this didn't work. Why didn't you show it just in the beginning in LabVIEW?
To check accurate that when it's detecting is that it's not detecting the ultrasonic, RGB, because it's more precise. And we're more confident about the code in general than the web.
Yeah, because sometimes we have problems with UART communication. Well, that's supposed to be the
I think one other of your main problems is that you improvise mounting the sensor. For example, the ultrasonic sensor is very
Yeah, the
improvised
ultrasonic
using masking tape.
Yeah, exactly. Yeah.
Something just disconnected.
Yeah, I just disconnected the power of the color reading sensor.
¿Dónde va?
¿Cuál es?
No sé.
Es el. Puedes conectar.
Well, as you can see, the sorting, all the PLC part is working as expected.
La segunda, de izquierda a derecha. Ground.
Well, almost the only mistake that I found is that if the system is not detecting the correct viscosity, it also classifies the bodies. And in that case, it should reject the order.
The integration.
There's no integration.
Yeah, the integration is not showing. No.
No sé,
So
No, here's the last.
as you can see now, the LED showing that the stacker is empty.
Okay, and the white one? So for example, in
I
this
have the counter for 3 bottles. I
Yeah,
can
but
expect-
Something about the
This is
labio
the
that I
blue.
noticed is I
This
think
is-
that
No, 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 no.
it needs to be from the
Blue,
start of the
red, and
sequence
white.
for
That's
the
the
labio
problem
to
of
start
the
reading.
LED. But I can
Because
show you
now
here that
connecting at the middle,
LED
the buffer is not reading. I don't know.
Shouldn't be the case
Shouldn't exactly.
because it's just streaming data to be visualized.
The thing is that it is starting, the labio is starting, the graph are taking the time because of the start of the
As you can
program.
see,
But
the LED, the second one, this one, should be turned on because it only dropped one. But I have the counter for all the 3 ones. I didn't expect to don't have all the bottles.
we have the position next
Okay,
in
that's
Y,
only the
the
electrical
viscosity that is expected,
Yes.
that is expected, the one that we want, and the RPMs and the color that the RGB should be reading. That was the main focus with the sensor that we had.
according to your PLC logic, at which moment you will reject an order?
We have
When-
to.
We will reject an order when it's stopped, when we have detect the bottle at the, how can I call it, the ultrasonic. And in the same, if the pin of the GPIO from the ESP sends a 1 to or to our Arduino while it's 1, it will reject the other. It's on the input here called bad ESP. Here, in this part. We are here.
Can you force the signal and simulate that it's going to reject that order?
Ah, ya está conectado. Está conectado.
You have to connect it, yeah.
As you can see now, I have here the branch of bad ESP. It's turned on, and it turned off this one. You see how? It works. I'll try it out.
I think the motor is not like that because the couple broke. Because it's making
But I
it's trying
explained.
to screen, but it's
Here I
not.
have the branch
Yeah,
for
so
the
it's-
I have
bad
it's
ESP
moving.
for
I
the
don't
bad-
But it's not that good
For the bad-
transmitting that one.
For the not correct viscosity.
Okay.
It will pass to this branch, and it will deactivate the original branch. When it's in here, it will go for until it detects that sensor. Once that sensor, it will wait 10 seconds and turn off the band, the conveyor belt, and then that clock go all the way, drop the bad viscosity, and go again, and come on.
Okay, there's the logic, but that must be implemented at this moment.
Yeah.
No, se murió otra vez.
I think that's enough for me, so I have enough evidence to grade you.
For the basic part.
The battery was off. Again.
Okay, but you should be aware of that.
No, yeah, it was.
Thank you.
Thank you. Now it's your time to move to the other classroom to present to Rodrigo Regalado and Professor Gami.
Oye, pero sí, sí.